Hi everyone, welcome to AIMS India's online classes as we are learning the language of chemistry from the past three sessions. Today we are going to continue our lecture, that is naming of compounds. How to name a compound. Let us start today's class. See, naming of the chemical compounds. In the previous sessions, we have learned what is an ion, what is a radical, what is a crisscross method for writing the chemical formula. All these we have learned in the previous classes. Today, we are going to learn the naming of the chemical compounds. How to name those compounds? Let's see. See, while there are many thousands of different chemical compounds, there is a very definite system of nomenclature whereby we can name or write chemical formulae for most of the compounds. See how, so we have a particular rules to write the nomenclature. Nomenclature is nothing but naming, how to name the compounds. Those rules we have to follow while naming the compounds, as we have a thousands of different chemical compounds. See how we have to start naming. Before going to that, all these compounds we have to divide into two main types. First one is binary compounds. Compounds containing only two kinds of atoms in its molecules. Bi means two types of two kinds of atoms in its molecule. H2O, CaO, NaCl. Sodium and chlorine, only two kinds of atoms in its molecules. So these are called binary compounds. Calcium oxide, if you take calcium oxygen, only two kinds of atoms are combined to form a molecule. Water, hydrogen and oxygen, only two kind of atoms are combined. So such compounds are said to be binary compounds. And the next type is ternary compounds. Compounds containing polyatomic ions, means more than two. It can be 3, it can be 4, it can be 5. Generally ternary, actually polyatomic means more than 5 atoms, 6 atoms are combining, more than 2. And ternary compounds maximum 3. Ternary represents the 3 compounds. See here, let us see naming of the binary compounds. How to name first type of compounds? Binary compounds. All binary compounds contain only two kinds of elements or atoms. Yes, the name of every binary compound ends with "ide". At the end we have to add "ide". Calcium oxide. Calcium and oxygen, only two atoms are present. That's why its name ended with IDE, calcium oxide. See, binary compounds come in three types. Again, there is a classification in binary compounds. Let us see what are those. There are three types. One is type 1, type 2 and type 3. What is type 1? The metal forms only one type of cation. Type 2. Metal forms two or more types of cations. Type 3 contains only non-metals. Again, in the binary compounds, based on the cations, metals forms only one type of cation. And two types of cations means which has the variable valency. Already we discussed in the previous variable valency. Iron shows +2 charge, +3 charge. Sodium has only plus, Na plus. Sodium forms only one type of cation. That's why that comes under type 1. Iron, if you take iron shows +2 and +3. Iron is forming two types of cations. That's why that comes under type 2. And the type 3 contains only non-metals. Cl2, O2, N2, like that type of the compounds. Let us see what is type 1. Type 1 binary compounds. The naming system for these type 1 compounds is quite simple and is found below. See, rules for naming type 1 binary compounds. See the first one. The cation is always named first and then anion second. Okay. In the given chemical compound, the first we have to write the name of the cation and name of the anion is second. How to identify cation and anion? Already we studied those. Positive charge containing one is called cation, negative charge containing one is called anion. This one we discussed in our previous session. See, a simple cation takes its name from the name of the element. A simple anion is named by taking the first part of the element name and adding the letters ide. Sodium NaCl is there. It is a binary compound only. Na is the cation, chlorine is the anion. Na sodium as it is we will write. And while writing the chlorine anion, chloride IDE will add to the compound sodium chloride. CaO is there, calcium oxide IDE we are adding at the end. Write the name for the compounds by combining the names of the ions. Let us see here some examples are given. Name of the compound calcium oxide. Calcium is the chemical symbol for calcium which forms cation. Oxygen is the symbol for the oxygen which forms anion. Yes. Whose root is ox? Oxygen. Calcium means calcium only. Cation. Direct name. While writing oxygen, it is an anion, right? Its root is ox. As it is an anion, we should add ide to at the end. That's why this oxygen became oxide. So, if you put these two together, the name of this compound is called calcium oxide. We write as usual lithium is the chemical symbol for lithium. We write lithium, it is a cation as lithium like. Whereas come to the N. N is a chemical symbol for nitrogen whose root is NITR. Add IDE at the end according to the rules. Then put the pieces together to get the name. Cation is lithium and anion is niter, and we have to add ide at the end. The name of the compound is called lithium nitride. Like that we have to name the type 1 binary compounds. Let us see the next one, type 2 binary compounds. For type 2 binary compounds, the metal present is variable valent, means more than one or two valencies it shows. The naming system for this type of compound is found below. Rules for naming type 2 binary compounds. See here. The first one is the cation is always named first and the anion is second. Yes, we know. Next one, the cation takes its name from the name of the element. Cation's name we'll write as usual. Include a Roman numeral to indicate its valency on the metal cation. Its valency we'll write in the brackets by representing with the Roman numerals. See, anion is named by taking the first part of the element name and adding the letters IDE. What is the difference between the type 1 and type 2? Type 1, it has only one valency, so we are writing directly. Whereas come to type 2, the cation shows two types of valencies. That's why in the brackets, after writing the cation's name, in the brackets with Roman numerals, we are writing its valency. That is the difference between type 1 and type 2. The remaining is same. Write the name of the compound combining the names of the cation and anion. See the example, then you will understand very clearly. Here we are naming the compound FeCl2. Fe is the cation, Cl is the anion, isn't it? Fe is the symbol for iron. So we have to write the iron. It is a cation. Fe is a variable valent. Therefore, Roman numeral is needed. As Fe is a variable valency, we have to follow type 2 rules. So, no, Roman numeral should be added. Chlorine is the chemical symbol for chlorine, whose root is chlor, and we should add ide at the ending. Then, at this point, we have iron chloride. But in the brackets, we have to write the Roman numeral of its valency. How to find that Roman numeral? Let us see here. We know that chlorine has -1 charge, but the reverse process of crisscross, we can find the valency of iron in this compound as 2. See here, Fe, isn't it? FeCl2. We have to go for the reverse. Chlorine is -1, already we know that. Then reverse crisscross, these two comes to here. And Fe, nothing is there means here 1 is there, that one goes to here. So Fe is showing 2, its valency. So in the brackets, the Roman numeral is 2. We have to write the Roman numeral is 2. Put the pieces together. Iron in the brackets, Roman numeral is 2, and chloride. These two represents its valency, because iron is showing variable valency. That's why in this compound, what is the valency of iron also we have to write. That is the concept actually. Okay. Now let us see the another example. Name the compound PbS2. Pb is a chemical symbol for lead. Yes, we know. Pb is also a variable valent. So we need a Roman numeral in the brackets. And sulfur, whose root is sulf, and it is anion, so we have to add ide. So it is sulfide. It is clear that we have lead sulfide, but in the brackets we have to write the Roman numeral valency. How to find that? But we know that sulfur is -2, isn't it? If it is -2, sulfur is -2, and already here we have a 2, isn't it? So the charge is -2, but in the reverse crisscross process we can find the valency of lead in this compound as 4, because already S is 2, but we have to cancel the equal number, so definitely there should be 4. Then only we can cancel and we can crisscross. Then if you cancel with 2, here it will come 1 and here it will come 2, that one we are crisscrossing. So based on the reverse crisscross process, the lead, its valency is 4. That one only we are writing Roman numeral for 4, we have to represent like this, and that only we are writing as a name, that is lead in brackets 4. It is the Roman numeral sulfide, lead 4 sulfide. That 4 represents the valency of lead in this compound, that is lead sulfide. Now come to the type 3 binary compounds. Type 3 binary compounds contain no metal atoms. All the non-metals only present. That is only we are considering as a type 3. Rules for naming type 3 binary compounds. See here. The first element in the formula is named first and the full element name is used. Let us see. The second element is named as anion. Root plus ide. Root means initial name. Chlorine means chlor. Sulfur means sulf. Like that. That is called root. Prefixes are used to denote the number of atoms present. These are just rules, ma. While writing the name, you will understand better. The prefix mono is never used for naming the first element. Let us see prefixes and suffixes. See, if only one is present called mono, 2 is present di, 3 is present tri, 4 is present tetra, these we will use for naming the compound. 5 is present penta, 6 present hexa, 7 means hepta, 8 present octa, 9 present nona, 10 present deca. If these are present as the prefixes, these names we have to use. Let us see one compound, NO2. Nitrogen is a non-metal, oxygen is also non-metal. So N is the chemical symbol of nitrogen. Since there is only one nitrogen atom and it is the first element, the prefix mono is not used. For the first element, we will not use any prefix. And comes to the second one, oxygen chemical symbol is the O, whose root is ox, and we have to add ide, isn't it? So it become oxide. But how many oxides we have here? 2 oxygens are there. If 2 is present, already we studied in the previous one, that is if 2 are present we have to use di. So there are 2 oxygen atoms, so we have also add prefix di to get the dioxide. Now the name of the compound is nitrogen dioxide. Nitrogen is a non-metal, oxygen is a non-metal. Then that is called type 3 compounds. Nitrogen dioxide is the name of the compound. See, next, write the formula for carbon tetrachloride. Carbon, simple, carbon means C. Chloride means Cl, but what they said, tetra means 4. So the compound formula is CCl4. See here, the chemical symbol of carbon is C. There is a prefix, no prefix before carbon in the chemical name. Therefore, there is only one carbon atom in the chemical formula. Yes, that's why C. Tetrachloride has the prefix tetra, means 4 atoms present. So chloride is derived from chlorine, whose symbol is Cl. Thus there are 4 chlorine atoms in the chemical formula. So the total chemical formula is CCl4, carbon tetrachloride, CCl4. Naming of ternary compounds. How to name the ternary compounds? It is the second type of classification. Till now we have studied the binary compounds. Again in the binary compounds, 3 types. Type 1, type 2, type 3. Type 1 is only single valency type metals. Type 2 is variable valency metals. Type 3 is only non-metals are present. All these we have completed. Now naming of ternary compounds means compounds that contain polyatomic ions, means more than 2 ions are present. See, a polyatomic ion is a group of atoms with an electric charge, means it will have some positive charge or it will have some negative charge. It will have some group of charge. Even though it is a group of atoms, it acts like a single atom. The names of nearly all polyatomic ions ends with the letters 8 or 8. Exemption C. Cyanide, ide, hydroxide, ide, peroxide, ide. These are the exemptions. These ions end with ide, which can trick into thinking you have a binary compound when you actually have a ternary compounds. Even though they are ternary compounds, we usually these compounds will have ide at the end. Because of ide present in that, you don't think those are the binary compounds, like those are ternary compounds only, but exemptions. Let us see naming ternary compounds. Follow the naming system for type 1 and type 2 binary compounds, but do not change the name of the polyatomic ion. Same the rules for type 1 and type 2, but we are not changing the polyatomic ions name. See, Na2SO4. Na means sodium. Sodium we have written. SO4 sulfate. Here see, FeNO3 taken thrice. These 3 reverse crisscross comes to Fe. Then iron in the closed brackets 3 Roman numeral, and NO3 means nitrate. Calcium hydroxide. Calcium hydroxide. CuNO2 taken twice. This copper Roman numeral we have to write Cu2, copper nitrate. NH4 twice, Cr2O7, ammonium. Cr2O7 is called dichromate ion. Ammonium dichromate. KH2PO4. K means potassium. H2 means dihydrogen. PO4 means phosphate. That is what we written, potassium dihydrogen phosphate. These are the naming of the some ternary. Ternary means more than here 2 sodiums are there, 1 sulfur is there, 4 oxygen atoms are there. Totally how many atoms are present? 7 atoms are present. That's why these are called polyatomic ions. More than one ion is present. Those are called polyatomic ions, and those are the ternary compounds. And some compounds will be exist. There are certain names of compounds which do not follow any systematic rule. Those are called trivial names or common names. Such names are called trivial names or common names. For them there is no rule. They'll have their common names. Chemists have not considered wise to replace these names by systematic names as they are widely understood by the common man. Because there is no systematic representation for those names, those are called trivial names or common names. Let us see those trivial names and common names for some examples. Common name for nitrogen hydride is called ammonia. NH3, generally NH3, we will not write nitrogen hydride, we will read this as ammonia only. Sodium chloride, NaCl, that generally its trivial name or common name is table salt. Hydrogen oxide means water H2O. H2, hydrogen, O means oxide. But we will not call hydrogen oxide. Like in our regular life, we will call that as water only. So, some of the compounds are famous with their common names or trivial names. So, potassium nitrate is there. This one we will write as the niter. Magnesium carbonate is generally called as magnesite. These are their common names or trivial names. For this, there is no rules and regulations. Those are given like that, and we are following they also like that. Okay, these are the naming of the compounds. In our language of chemistry, we learned what are ions, radicals, atoms, molecules, and how to name the compounds also. How to write the formula by using crisscross rules also we have learned. Okay. Thank you. Thank you so much for watching our video. Please do subscribe to our YouTube channel Aims Today for latest updates and the recorded videos. Thank you. Thank you so much guys.